Hello, students. Hope you did well with the exam. Presenting here to you the solution of your paper with the exam held on 19th March 2025. So, as you can see, it is a 70-mark paper. You are getting 3 hours to solve it. Section A has 2-mark questions which are compulsory, and they are 7 questions. They have been picked up from your uh, first unit, second, third, fourth, and fifth. Okay, then the section B, any 3 questions you have to do, and the choice given is for 1, 2, 3, 4, 5. So out of 5, you have to pick up any 3. These questions, here a numerical has also been included. Section C, you have to pick up, and they are 7-mark each section, B and C questions. And here, like a lengthy experiment along with numerical, or here a derivation along with the numerical. Once again, you are having derivation along with the numerical. Here, section 6, 7. So let us begin to solve the paper. Paper was a very easy one compared to your previous year papers which have come. So let us start solving your question paper. So state the assumptions made by Planck to explain black body radiation. Now see, this is a 2-mark question. So just write 2 points because you are getting only 3 hours to solve the paper. So Planck made 2 assumptions, that energy of an oscillator is quantized, that is, it occurs in multiples, or E is equal to NH mu, where N is 1, 2, 3, 4, 5, 6, H your Planck's constant, and mu the frequency. And the oscillator emits or absorbs energy in discrete packets known as quanta. Okay, define the term wave packet. So wave packet, you must be very familiar with in your quantum physics syllabus, that a wave packet is basically a combination of waves with about the same momentum. Combining waves into packets can provide localization of the particles. If you want, you can also show it diagrammatically. It is 1-mark wave packet. Acceptable conditions are you just show this diagram. Now the term skin depth with necessary formula. Depth of penetration to how much it enters the electric field depending upon 1 upon E times, that is exponential of its initial value, is skin depth. It is inversely proportional to attenuation constant. So for writing the definition, you will get 1 marks, and formulas in your syllabus, they are for dielectric, for conductors, for non-conductors. You can pick up any one formula and just specify the symbols, what they mean. Like skin depth, under root 2 omega mu sigma. Sigma will represent conductivity of the medium. It is in your syllabus. And then this is sigma, pi, F is the frequency, this way. Center in Newton ring experiment is dark. Explain it. So the reason for center being dark, see, if you are giving the word destructive interference or path difference, you will get your 1 mark, and you will mention the air film thickness being 0. This way you will get your 2 marks. These are the 2 points. Spontaneous and stimulated emission of radiation. See, it's a 2-mark question. You can write 2 points. Or if you want to exaggerate, you can say that intensity here is less. In this case, it's high. This is a natural process, spontaneous. Stimulated is not a natural process. In spontaneous, does not require external photon as a stimuli, but in stimulated, it requires. Now, state the formula to calculate the cutoff parameter and number of modes in the fiber. Okay, so the V number formula is 2 pi A by lambda into numerical aperture. Do mention what the symbols are, because Some book carries A, some carries R, some carries X. So you should mention what the formula is. So in this case, A is the core radius, lambda wavelength, and Na is numerical aperture. And the number of modes, V square by 2. Quantum well and quantum wire. Quantum well, electrons are confined in one dimension. See, if you mention the word one dimension, two dimension, you will get your 1 mark. And you can write something extra that electrons are not confined along the wire, and here they are, so you get your other 1 mark. Now, Schrodinger equation is one question which is asked approximately every year in a question paper. Once they give the case of time independent, other time they give the case of time dependent. So, see, time independent Schrodinger wave equation, it is a 7-mark question. So you have to break these 7 marks of how you will start getting your 7 marks. So first you will tell about the plane monochromatic wave and the formula for that wave. You will mention what the terms are, 2 pi I upon h e t minus px, like p is momentum, e is energy, t is time. And then you will break these coordinates into space and time. See, x and t. So the wave function has been written as a multiple of space-dependent coordinate and time-dependent coordinates. And now they are asking us the time-independent part. So we will take up the x coordinate. And for Schrodinger, we differentiate twice with respect to x and once with respect to time. These differential values we put in the time independent equation and we get the answer. So you can see you will get round about 2 marks for this much. Differentiation part, if you show clearly, 2 marks. Final equation comes out. And in case you have time, you can show that in 3D it is written like this. And they have asked about wave function. So wave function, they have asked in section A also the same question. So it is providing complete quantum mechanical description of the behavior of the particle. Okay, describe electromagnetic equation in free space. Prove that EMT waves propagate with speed of light. Now, see, free space, meaning no charges present. So you first tell that in free space, charges are not there and these factors become 0. This is 1 and this is this. Then change the Maxwell equations, write them in free space. You will fetch easily 2 marks for this much step. And then the third and fourth equation, you take curl of the third equation and put these values in equation 4. Solve them, subtract, use vector identity step by step and get the answer. So till here, see, 2 above you have got for explaining what is free space, putting them in Maxwell's equations, and then subtracting the third and fourth equation by taking curl, you get this. So around about 5, 5.5, or even you can get 6. And for H, see, once you do in EMT wave for electric component, then do it for the magnetic component. Then last step, they are saying that show it is equal to velocity of light. So I think 5 to 5.5 there and another 1.5 mark here. Compare this equation with general wave equation and then this is equal to speed of light in free space. Okay, explain interference in thin films due to reflected light. Okay, and conditions for bright and dark fringe. Draw a good labeled diagram. Do as much labeling as you can. Incident ray, reflected ray, refracted ray, then this path difference, and then step by, for this diagram itself, an explanation, you can fetch 2.5 marks easily. Then step by step, you write the equation. BH is the path difference that has been suffered by this ray in air and media. See, BD plus DE in the film minus BH in air. And when it is in the media, you multiply it by refractive index, and then the three famous triangles you take to find the value of this thickness of the air film and angle. Put these values in the path difference expression. BD and BH are found by triangles. Their values are put. Tan is sine upon cos. This value is then put here. Multiply numerator and denominator by sine r, and you get the answer for path difference. All this detail has been covered in the lecture series and in book also, and you get the answer. They are saying get the conditions for maxima and minima also. So maybe if you get 5.5 till here, another remaining 2 marks you will get when you apply the condition of maxima intensity, that is path difference, and minima intensity, and you get your answer. Process of spontaneous stimulated with diagram, and here they are asking you to derive Einstein's coefficient. So see, derivation of Einstein coefficients will be round about 3.5, and process of absorption spontaneous and stimulated will be your another. So 4 and 3, this is how the breakage will be. So show the diagram. See, this is getting absorbed, stays here, comes down on its own. It is spontaneous. When you give an external source of energy, it becomes stimulated. Okay, then you derive the expression for relation between Einstein coefficients, that absorption is equal to spontaneous plus stimulated, and you get the answer. Okay, what are type 1, type 2 superconductors? See, they are saying to explain type 1, type 2. So this will carry, and then you have a numerical along with it also. So again, the breakage of marks will be 4 and 3. So 4 and 3 mark breakage. Type 1, type 2. Draw the diagram. Show that it is a reversible effect. They are soft superconductors. They are single elements. They carry poor electrical current. And for type 2 also, draw the diagram. So these diagrams itself, if you draw them properly, you can fetch easily 4.5 to 5 marks. Show the mixed state, complete diamagnetism, normal state. Tell type 2 are hard, type 2 are alloys, or they are a combination. Type 2 consists of 3 types of magnetic fields, and type 2 are not fully reversible. And then they are asking you this numerical. So the numerical formula you use is Hc equal to H naught into 1 minus T square by Tc square. So you put the two values that you have been given. Simplest solution is divide them. Once you divide, you get your Tc value, and in order to get Hc, put this Tc value up there in that equation, and you will get your value of Hc. Okay. Next question, Davison-Germer experiment with diagram. So proper diagram, well labeled, good explanation. Easily you will get 3.5 to 4 marks, and then you explain that how the heated filament is carrying electrons, electron beam getting scattered at different angles, nickel target here, and then the plot, and then try to concentrate more on the diagram where this bump is observed and at which angle, and you are getting from de Broglie concept the wavelength, and when we calculate it through crystal structure concept also, lambda comes out same. Hence, de Broglie experiment gives a proof that de Broglie waves or matter waves exist. So if you find that it is too lengthy, try to cut it short. Till here, be very clear and precise. After that, if you want, you can leave out these diagrams. Just explain it in short that lambda through crystal structure and lambda through de Broglie, H upon P comes out same. Okay, a numerical here. It is on wave function. So wave function in lowest energy, n equal to 1, and at the center of the box, x is equal to L by 2. So your wave expression normalized, you put the value, this is a square. So 2 upon L sine square pi by 2 equal to 2 upon L. Probability in the interval 2 upon L into del X. Now L has been given as 20 angstrom, change it into meters. Del X is 10 angstrom, change that also into meters, and you get the answer equal to 1. So there is a probability of 100% of finding it here. Though practically this is a bit not possible, but this has come. Next, define work energy theorem. That means the pointing question has come. So you can just tell the Maxwell's third and fourth equation, multiply one by E, the other by H, subtract, use vector identities, put their values in the expression, and then you get the famous pointing equation, which represents that electromagnetic wave consists of the sum of magnetic field elements and electric field elements, and it tells about the conservation of charge. Okay, now the numerical, this numerical has continuously been asked from 3 semesters, and the values are also same. S equal to 1000 watt, distance of lamp, 2 meter, 5 meter, or 1 meter. So from pointing expression, total energy is equal to P upon A. A here will become 4 pi r square. R given is 5. So S is 1000 upon 4 pi into 5 square. This on solving gives you 10 upon pi. So from pointing theorem, S is equal to E cross H, E H sine 90, because E and H are perpendicular to each other. So, and E upon H is equal to 377 or 376.72. Now, these two equations you have got, you solve them mathematically and you get the answer. One more thing. See, in the question, it is saying calculate the electric and magnetic fields of radiation. So you will take the average and multiply it by root 2 here. And H also you find from the two expressions and multiply by root 2. Okay, Fraunhofer diffraction at single slit. Diagram, 3 marks along with good explanation of the diagram, how single slit works, what the expression comes out as, resultant intensity expression, just say that intensity comes out as this much, and once you put the values, divide it by the main intensity to show that it is round about 4.5% of the principal maxima. Again, a numerical. Numerical is, I think, of thin films. So destructive interference of light in reflected system, 2 mu t cos r is 2n lambda by 2. T comes out n lambda upon 2 mu cos r. Mu is 1.5, r 60 degree, lambda 5890 angstrom, change it into centimeters, and cos 60 degree is half. For smallest thickness, n is equal to 1. So even if till here you have written out of 7 marks, 3.5 to 4 marks. Last marks remaining, put these values correctly, change all the units properly, and you get your answer. Explain the term acceptance angle, acceptance cone, numerical aperture, and diagram this. Okay, so proper diagram with labeling, as you can see in front of the screen here. And then numerical aperture, acceptance angle, simple step-by-step derivation, and you get it for this refractive index. They are asking you this derivation, numerical and this here. Helium neon laser, so that means next year it should be ruby laser. Helium neon laser, gaseous laser, once again a good labeled diagram. And then the construction part and the diagram part 4 marks. The energy level part carries the rest of the marks. So 4 and 3, I believe, will fetch you your full marks for helium neon laser. Okay, Meissner effect, once again, try explaining it with the diagram. So you will get 2 marks for Meissner effect, 2.5 and 2.5 for perfect diamagnetism and 0 resistivity. Simple, B equal to 0, B is mu naught H plus M. And this you get as diamagnet. 0 resistivity. They are the two independent properties of superconducting state of matter. Then top-down approach for fabrication of nanomaterials. So they are saying you explain this term. 1.5 to 2 marks. Then they are saying describe this in detail with a diagram. So again, break the marks properly. 3 plus 4. What is top-down approach? To nanomaterial involves reducing bulk materials to nanoscale structures by using externally controlled tools to cut, grind, and shape the materials. Then you can take up the CVD technique, draw the proper diagram of chemical vapor deposition technique, how it gets deposited, the gas inlet, gas outlet, quartz tube, and explain it. Write 2-3 advantages also, because remember, these are 7-mark questions, but break the marking as I am showing. Thank you.